Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Mark Brooker's fascinating blog post on versioning versus coordination in distributed database systems. The core argument? Versioning wins, hands down. It's a game changer.
I'm intrigued. So what's the setup? Why is this even a problem?
Imagine a sharded database, multiple replicas, concurrent queries. The kind of architecture needed for serious scalability. The challenge is ensuring data consistency when multiple transactions run simultaneously. Think of two transactions, T1 and T2, accessing and modifying the same data. We need to guarantee that T1 sees a consistent snapshot of the data, regardless of what T2 is doing. This is where the battle between versioning and coordination begins.
And traditional coordination methods, like locking, fall short?
Exactly. Locking, while seemingly simple, creates bottlenecks. A reader, T1, holding a shared lock can block a writer, T2, reducing concurrency and throughput. In a distributed system, managing locks across multiple replicas becomes a nightmare. It's a scalability killer.
So versioning is the solution. How does that work in practice?
Instead of directly modifying data, a transaction, T2, creates a new version. Older transactions, T1, see the older version, while newer ones see the updated one. The storage layer needs to provide a way to select the correct version based on the transaction's start time. It's elegant, isn't it?
It sounds incredibly efficient. No more blocking, no coordination overhead between transactions. But how do you choose the right version? And how do you manage all these versions without losing track?
Great questions. Choosing the version depends on the consistency level you need. Read after write consistency, for example, ensures that a transaction sees the results of previous committed transactions. In Aurora DSQL, they cleverly use physical clocks to determine the version, eliminating the need for a central version authority. Brilliant!
Physical clocks? That's interesting. I see. But how about managing all those versions? That sounds like a huge storage challenge.
It is a challenge, but the blog post suggests a clever approach. Instead of tracking every single version, you can rewrite queries to specify a version range. For example, a transaction could request data with a version less than or equal to its own timestamp. This simplifies version management significantly. It's a clever optimization.
So you're saying that by cleverly using timestamps and versioning, you can essentially eliminate the need for complex coordination mechanisms in most RED operations? That's a pretty bold claim.
It is a bold claim, but the blog post makes a strong case. By avoiding coordination, you gain significant improvements in throughput, scalability, latency, and system design simplicity. It's a paradigm shift. Of course, there are trade-offs. Managing versions requires careful consideration, and the approach might not be suitable for all use cases, especially those involving very long-running transactions.
I agree. It's not a silver bullet, but it certainly seems like a powerful technique for many distributed database scenarios. The blog post highlights the importance of considering the trade-offs and choosing the right approach based on your specific needs. A very insightful analysis.
Precisely. And that's why this blog post is so valuable. It sheds light on a fundamental concept in distributed systems, showing how a clever application of versioning and physical clocks can dramatically improve performance and scalability. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of distributed databases. Goodbye.
Bye-bye.